Okay, this is our Lesson 8 group meeting quiz.
Yay.
And I'm going to start question 2. Which of the following... Huh?
I said, let's hope B doesn't die in the middle of it.
I know. Oh, getting sick. Which of the following variables is our categorical? Okay. A randomly selected brown toothpaste. Boom. Did you get the same one?
Well, I mean, we.
No.
This is like
categorical is. I meant the exact opposite of what I just did. Sorry. The numbers of animals in the local zoo and age in years. That's what I meant.
You think those are variables that are categorical?
Yes, because quantitative is numbers and no. Oh my gosh, I'm the exact opposite. I was right the first time. Categorical is numbers. I know. I know what I was thinking. You saw that I knew and then I doubted myself. Yes.
Yeah, like whenever you second guess yourself and you're like, wait a minute.
What time is it? It's almost 8 o'clock. Okay.
Almost 9 o'clock over here.
I'm sorry. I was forgetting the time change. Okay.
Oh, it's not like I have anything better to do right now.
All right, number 3. The mean IQ is 100. 120 randomly selected statistics students took an IQ test, and the mean of their scores is 112. Which of the following statements are true?
Okay.
1 second, I'll be right back.
Okay.
I knew what I meant. Okay.
Put those big eyes.
Okay.
All right, so question 3.
Okay. I think that it's 100 is a parameter.
Yeah, because it's saying like that's in the entire U.S.
Exactly.
So that would be the mean for the U.S., which means that's the parameter, like that's the goal. And then, unless 100 is a statistic, because that's national. That's a national number. But then 112 could be parameter.
Okay. All right, so for number 4, I love that they put Rotham City.
Wow. Sounds like another city we know of.
Okay. I got stratified sampling.
Yeah. No, I can see where you got that.
That's just the example I have under stratified sampling. So.
Yeah. No, because it's saying it's got 4 distinct neighborhoods. The property values are very similar within each neighborhood and then vary from neighborhood to neighborhood. One has very low property values, extremely high property values. So what type of sample should we collect to gauge the residence? Yeah, no, that makes sense.
And then for number 5, I got cluster sample.
because it's used to be. Ugh.
Because it's the school systems, and then
Yeah.
they choose the district and the teachers, and out of the 4th grade, it just really goes along with the cluster.
So like clusters, it just clusters upon clusters upon clusters. So it's like a specific school system, like a particular district, and then you randomly select teachers of a random grade. So that's kind of clustering things together, unless it is a systematic random sample.
No. For number 6, I thought that was going to be that one must be a voluntary response sample, right? Has to be, because it's not the other.
If you're thinking about it, drawing names from a hat, what kind of sampling do you think that would be? Because every person who attended would draw. At the end of the season, 6 names were selected to receive door prizes. Wouldn't you think that, it can't be systematic because they didn't have a system going on? So wouldn't you think that it was simple random sampling?
Actually, I think it'd be a stratified random sample. No, maybe not.
Because
I don't know.
If you're just drawing names out and you have a particular number that you're drawing out, that's a simple random sample, because it's kind of one of those examples that's in your face.
Okay, maybe, yeah.
I mean, you could put stratified a random sample if you feel like that's what it is, and I'll put simple random sample.
No, I don't anymore. I just read it. Okay. Number 7. I have 31.
A special interest group is conducting a survey regarding wolves in Yellowstone. To adequately gauge opinions on both sides of the political spectrum, researchers took the list of registered Democrats and selected a random sample of 100 people. I feel like that is kind of systematic, wouldn't you say?
I think it's stratified.
You think it's stratified?
Because stratified says it divides the data into smaller groups, so it'd be Republican and Democratic. And then within those, a simple random sample is taken.
Mm-hmm.
So it sounds like it says simple random sample of 100 people. I think it's stratified.
Okay, now we come to question 8.
Can you tell I have 2 sets of notes? I'm like,
yeah, you're bouncing your head from one note to the other.
Because they both have different examples in them too.
Yeah.
One's from the book and one's from tutoring.
Yeah.
Okay.
To
blinking. Yeah. Stop it. We can't. Just put the blanket on his feet. It's on the floor. Okay. If the dog licks, he'll throw up.
Oh. Mm-hmm.
Okay. I'm ready.
All right, let's calculate the mean of the amount spent. Awesome.
Okay, my spreadsheet's empty.
That's weird.
Oh, I found it. Never mind. I just pulled up an empty one.
So it's really easy to kind of like do the calculation. Even though there's like 80 something numbers, there's actually a way you can do this. So you know that f of x bar in the top? Or you can go to insert and then you can do insert equation. Oh, gross. And then weird. I actually know one of the names on this list. Anyway, and then you can do like the mean. You see what I'm talking about?
Yeah. We put in the average.
Yeah,
Oops.
you can actually look at the average.
Yeah. One
And
second.
you can do instead of like being like B1 and like do it like that, you can actually do B1 through B86.
Whoops.
You light it.
Yeah. No, I know how to do that. It just won't let me out of this. What is happening?
There's so much rage.
I'm hitting the X button and nothing's happening. Shane,
Let me. I can do.
I'm just gonna minimize it. Oh, I can't. Okay, I have to reload this. 1 second.
Ooh.
That was annoying. Yes. Okay, I got it. We're good.
Oh, that's. All right, screen. It's time to load.
Okay.
The standard deviation one is going to be a little difficult, but all right. And now.
What's if Shane's looking again? Oh. Okay.
So apparently.
Okay, let's move past this Excel thing because it's just not working. Like, it's just literally not working.
I'm actually about to do it from here, so.
And I'll do it on my own. Probably at home. It's just not working. It won't even let me close it. can minimize it. Okay. Let's make a histogram now. Okay. Okay, let's go together. Let's just go to number 11 really fast.
So
Does it
11.
come here? Yeah. Okay. We couldn't do that stuff together with the Excel sheet anyways.
Yeah.
Where is it? Jessica Muir and her research team measured the body temperatures of a sample of diving elephant seals. A thermistor was placed at a specific location on each seal to measure its body temperature, tend to decrease as they dive. So, they represent a temperature. Okay. Hepatic sinus. Huh. Okay, so we just have to fill in the chart. All that was garbage. Number 11, what is the value of the number that goes in the position mark with the A, or with an A in the table above? Okay, cool.
So it's x minus x bar.
Where is my pencil? Oh, there it is. All right, so first we figure out the mean, and then we subtract the mean from the value.
Let me get a calculator. Do that as well. So I don't look like I'm just sitting here.
The tutor I had today was doing all this in his head.
I didn't do that. And I'm like, nope, I can't do that.
Some of the things you were doing were like negative 0 point, something, something, something. It's like,
Yeah.
really? And I'm still typing and he's figured it out.
So it's 38.07.
I got 30.46. Probably right, but I'm going to go over this again. You're right.
Okay, I was like, I know I didn't do it. It's like, I kind of have to pay attention to numbers. Because sometimes I'll type in a number and then I'm like, crap.
38.075?
Yeah, 38.075. So pretty much 38.06 because we're rounding it up. And then, so then I think we subtract that from 37.91, correct?
Yeah. Wait.
And that's probably
you subtract the mean from the value.
Yeah.
So I had the exact same problem today in class. I mean, in tutoring, and we did the opposite.
What?
Yeah. Here we do the subtract the
mean minus.
Our answer, we did 37.91 minus 38.075, and we got negative 0.165. That's just what we did in class. I mean, or non-class in tutoring, and that was like a few hours ago.
So it's 0.165. So would that be negative then?
Yeah, it's negative. Well, this is what we just got. Negative 0.165. 0.165.
Okay.
But hey, this was just with the tutor. Maybe it's wrong. Maybe it's supposed to be the other way. But this will be good to know.
So the value is, so it's the value minus the mean, correct?
He kept saying mean, subtract mean from the value.
That wouldn't make any sense because it would
be different, I know, but that's just what he kept saying.
Then it would just be a positive 0.165.
That's just the answer that we got.
So it's just the 0.165 is the answer, but
We got negative, yeah.
yeah. So you just flip the equation around and then you add the negative.
Shane, is he licking? Okay.
All right, so now we take the mean minus the value and square that.
Hold on a second. Just put the blanket on the top. It's easier. What quantity?
So now we have to figure out b, which is going to be the x bar squared. Hold on, I'm opening up my...
We did that too. I have it if you want.
What is it?
0.681 rounded.
0.681 rounded. Yeah, but is it... Okay, so I'm confused about 11 because it's a negative number, like, even though it's the mean minus the value.
We just did the
You see
value.
what
I know. We did the value minus the mean.
Okay, okay. I
Except
see.
saying subtract the mean from the value.
Yeah.
Okay.
And you said you got 0.681?
Yeah.
Is that what you said? Okay, and that's positive?
Yeah.
Okay. Yeah, I can see that. Sorry, for some reason my neck is killing me. 13.
Okay.
Quantity
I got that
equal to the sum. You said the variance?
That's what I got.
Quantity is equal to the sum of the numbers in the squared deviation. I would say that too, because you find the mean and then you pretty much find the standard deviation and then the variance is squared. Oh, wait. No, that's standard deviation because you find the mean, subtract it from the value, and then you square it. That's standard deviation. One of my roommates is a stats major and she was explaining standard deviation to me one time and I was like, oh, wait.
We actually have standard deviation in the next one. I can't hear you. Oh, I hear you now. We're good.
Sorry, I wasn't talking. I was reading the next question, like I was mouthing it. So the next one, oh gosh, the next one isn't going to be too hard. Just because there's only like 4 numbers and finding the standard deviation for them isn't going to be that hard. So the B column is the standard deviation. That's what I think of. Is the entire standard deviation. Sorry. Ugh.
Okay.
The right things that I'm going for. Oh my gosh.
Okay.
No, I'm just trying to get the phone propped up just because I want to do work and then talk to you at the same time. Point 9. And the last one is 38.1.
Okay. Pick up.
Dang it. There we go.
What did you get? I got 0.715.
Yeah, I did too. So it's 0.715. We could, yeah, nope, that stays the same. I was just thinking if we could round it up at all. Under certain conditions, the standard deviation can be negative.
No.
Not even. In the same study, the researchers placed thermistors, temperature sensors, chick starburst.
Stop it.
Sounds like you're having so much fun right now.
Emails, they come in like waves.
That
I wish it was fun. It was just emails. Okay, which location resulted in the most consistent temperature measurements from one seal to another?
Extradural?
I think so.
Well, sample size was 3. Arterial. That's the arteries, this is the skin, and this is their nose.
Yeah, because the standard deviation's low. That's my guess.
Yeah. I mean, the most consistent would, I mean, it seems like it's extradural. Well, what about the arterial? Is a higher standard deviation like better and more consistent, or is a lower one?
I'm almost certain.
Yeah, the extradural, because it's the lowest number out of all 3. It just seems like a better. Yeah, no, I can see where you're coming from. All right, on to number 17.
Okay. I feel like these ones are pretty common sense, right? Just look at the picture and
Oh, and I found the average from that one question we were having trouble with.
Which one?
The one from the Crossroads purchases.
What number?
I think it was 8. Because you were trying to find the mean.
Yes.
And I was just like, awesome, I can do this. And I did it in the Excel sheet, just using the average tool. And it came out to be 4.771.
Nice. I'm going to do that as soon as I get home. I can't even close the Excel sheet on the computer.
I constantly sitting there, I was like, I know how to do this. And I did it because I learned it in my my computer classes back when I was in high school. So, what is the third quartile?
Do you want to go over these ones?
I mean, kind of just because it's been I've, slept since then.
I think it stops 8.
And it's 8.
I think
It stops at the third quartile. So the first line of this little box plot, that's the first quartile. The middle line is the second, or the halfway point, the median. And then that third line, right where it stops at 8, that would be the third quartile.
Yeah.
See, that is pretty easy.
Right. And then 18 is just 50.
50?
Mm-hmm.
So now we move on to question 19 about the normally distributed population.
Okay.
Oh, now we're dealing with the 68, 95, and 99.7% rule. That's always fun, right?
Okay.
So this one is pretty point and shoot because you're
nitrate concentration.
I don't want to know how much nitrate is in the Rexburg drinking water. That's terrifying. Maybe I'm not.
Oh yeah, that's easy. We just do those two. I got, that's it, right? Yeah. 2.055. Is that what you got for number 19?
Yeah.
Okay.
Yeah, because did you use the 95 as the because it's the 68, 95, and 99.7 rule, because this is the exact equation that you have to do for it. So just kind of reversing that. I can, yeah. Estimate the standard deviation of the measured nitrate concentration in Rexburg's drinking water. So the standard deviation, if I'm correct, because it's 2 standard deviations away from the mean, it's 95. If I'm not mistaken. But you also have to put it in the, like, it's the 3 decimals stuff. And it's, I think, hold on. I used to know this number. I knew these numbers by heart. Okay. It should be it's 0.955.
I got 0.6576.
0.6576?
Yeah.
For 2 standard deviations over?
I think so.
And that was what number again? I'm sorry.
Number 12.
No, what was the number that you got? Because I'm just trying to make sure my math was right.
0.658. But I'm not 100% certain about that one.
I might have been wrong with my math just because I'm going strictly by the numbers in the rule. But that's just me.
It's okay. Whatever we aren't certain about, we'll just figure out.
Yeah.
Lily, stay here. What is the probability? Let's go number 22. What is the probability that a randomly select? Wait. Oh, I don't know 21.
21 is the.
No, I know the idea. I just don't know the answer.
Well, we already one answer. It says between what two measured nitrate concentrations do approximately 68% of the data values lie? So we already know what the mean is. And we also kind of know what the standard deviation is. So
I don't know that one. I don't even know how to do that one.
you just don't even want to.
I'll go through later.
Yeah, I'll probably do the same thing.
Right, I'll go through the notes and everything.
Yeah.
Okay, number 22.
What is the probability that a randomly selected student will score above 542.3 on the GMAT?
Okay, so it's 600 minus 542.3 over, what are you, warm me up some pizza, will you? Why not? I'm hungry. Over 120.54 divided by the square root of 15, which is whatever that is.
Wait, you said the square root of what?
Of, wait, where did I? Oh, I'm sorry. I was doing a different problem or a different formula.
Yeah, I was about to be like, what? What are you on about? Because it's the value minus the mean divided by the standard deviation. I think that, yeah, that should be what it is.
I'm going to do these with the book just because I didn't really fully understand above or under or below, I mean.
Yeah.
Yeah. I'm going to do, there's a lot of these.
Yeah, I don't understand. It's sad because some of these, they like, you know, whenever you're in school and you kind of look at it and you're like, I know how to do this, but I don't know how to do like the reverse process. You know?
Yeah. Okay. know. I'm trying to see if there's any. This isn't good. We have our quiz on Wednesday. Tomorrow.
Yeah, that's gonna be fun.
I think I'm just also kind of tired. Maybe I know this, but I'm really tired. Okay.
Yeah. No, I get you. I'm starting to get a really bad headache. Math has always given me a really bad headache.
Okay, well, I'm going to post this video, and then we can do the ones that we don't know.
Yeah, we can most likely just try and
But our
borrow.
video is posted. Hooray.
That's always nice.
Right. That's done. We get some credit. Okay, cool. And then next for this week, do you want to meet? I mean, for Thursday's one, do you want to meet on Thursday just because we have our test on Wednesday?
Uh-huh. Yeah, no, we can meet on Thursday.
Okay, cool. I'm going to study. I'm kind of frustrated right now.
It's going to be kind of one of those things that helps distract me because of surgery on Friday.
Yeah.
And guess what day is Friday?
What?
The 13th.
Oh, it is? I was like, there's no holidays on Friday.
Oh, I just forgot the standard deviation for question 9.
Okay.
1.912.
I'm going to stop the broadcast and post it, okay?
All right, awesome.
Okay, I'll talk to you Thursday.
Yeah, awesome. Bye.